Welcome, friends, to another session on What, Why, and How by Stats SD. The topic of today's tutorial is arithmetic mean, calculations using direct and indirect methods. This is part one of the series for ungrouped data. In the next tutorial, we will look at group data calculations using both direct and indirect methods. Before I begin, I have a chart in front of you. It says average time spent on social media in 2023 by platform. If you notice, it shows that people spend maximum time on TikTok, which is 53.8 minutes. Next is YouTube, 48.7 minutes. Twitter, 34.1. Instagram is 33.1. Now, why did I share this chart with you? If you notice, you may spend more or less time on one of these platforms, but these figures are nothing but averages or the mean time spent by the users on these platforms. So, averages or mean help us make sense of the data average. What is arithmetic? The, the arithmetic mean is simply mean or the central tendency of a set of numbers calculated by averaging the numbers. We have different types of mean. It could be harmonic geometric mean, but 90% of the time we use the arithmetic mean. Mean is mean itself. Now, why study mean? As I told you, first of all, it helps us understand the data. If we have lots of data in a field, maybe we might have minimum numbers or the maximum numbers, but the number around which a lot of other numbers are clustered is one, and mean is one such number. It is the effective tool to summarize the data. When I say the average Indian shoe size is 6, it means that though there are men and women who prefer maybe 4, 5, 7, or 8 sizes, but the majority prefer number 6. Mean helps us in decision making because resources can be allocated as per average and not individual. So government of Maharashtra, when they are spending on healthcare, they might calculate what is the average size or age of their citizens, accordingly allocate a budget. Mean can also help compare two data sets. So the mean for data set 1, if it is higher, we could make an inference or a conclusion that maybe the observations in data set 1 are greater in value. Finally, mean can also help in terms of further statistical analysis like calculation of variance, standard deviation. Now, coming to the this 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 is important possible ways how you can calculate arithmetic mean. You can have group data or an ungrouped data. In the next slide, I will explain what is ungrouped data. Data, 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 data which is not bounded by upper interval and the lower interval would be ungrouped data. So numbers 55, 65, 75, 85 would be classified as ungrouped data. Whereas if I have a class interval 50 to 60, 60 to 70, 70 to 80, it would be classified as group data. To calculate mean for ungrouped data, we can use a direct method, and also the tables in front of you, if you notice, the left hand side table is without F or without frequency, and the same data is available with frequency. What do I mean by frequency? Assuming I have 7 observations in table on the left, and I have observations related to the earnings of 7 people. Does it mean it doesn't have frequency? To make it simple, actually the frequency for each observation is 1. That means one person earns 100, the another person earns 120, and so on. So can I fill the table here? So rather than keeping the frequency as empty, I will make it as 1, 1, 1, 1, year, and year. If you notice, the below formula is summation x upon n. So the total sum of all the observations divided by the number of observations, that will give you the mean. To make it simple, I have actually included f, or the frequency. Even if you keep the frequency as 1, it would not affect the formula. On the right hand side, I have the same data, if you notice, but in this case, I have 3 as a frequency against earning of 100. It specifically means there isn't only one person who earns 100 rupees, but there are 3 people who are earning 100. Similarly, 6 people earn 120. The highest amount earned is 220 by 75 people. Now, for a further calculation in the direct method, we need to find the product of frequency and earnings. So, on our left hand table, we have 100 multiplied by 1, that is again 100, 120, 140. So, here the frequency is 1 and multiplied by earnings is your fx. In the right hand table, we would have 3 people earning 100. So, the sum total would be 300 for the first row. 6 into 120 would be 6 zeros are 0, 6 twos are 12, 1, 7, 20, and so on. So I have completed the table for you in the next slide. If you notice, I have taken the sum total of the frequency and fx. So on the left hand side, the sum total of fx is 1120. Now, if you see the formula given, x bar, which is nothing but the symbol for mean, it says 1 upon n summation xi. So if I've taken the summation fx, it is 1120. So can I calculate here? X bar is equal to summation fx, which is 1120, and if I divide it by the number of observations or the number of people, I would get the mean as 160. So 160 is the average earnings of the data collected from 7 observations. Coming to the table on the right hand side, I have summation fxi. Here I have x bar equal to, the summation fx is 34040. But if you notice, now I don't have only 7 observations or data for 7 people, but actually I have data for 175 people. So I divide that by the summation f. If I calculate, the average should turn out to be 194.514. So we observed that using the direct method, Our formula is summation fx divided by summation f. In case the frequency is not mentioned in the table, please consider the frequency to be 1 and calculate the summation fx. Now coming to the indirect method, which sometimes I suggest to all my students, there's a slight deviation or something called as step deviation. Now, rather than knowing the mean, I assume a mean. So, assuming in this case, I take 140 as my assumed mean, I need to find deviations from the assumed mean. So, I have d equal to x minus a. Very specifically, I would take x1 observation, that is 100, subtract it from the assumed mean. So when I subtract 100 from 140, my answer should be minus 40. For the second observation, 120 minus 140 should be minus 20. 140 minus 140 should be 0. 160 minus 140 is 20. The same has been calculated in the right hand table. So if you see, I have also considered the assumed mean here to be 140. Now, as I told you, I considered the frequency to be 1. So, Fd rather than Fx, we would calculate minus 40 into 1, again minus 40, minus 20 into 1, minus 20. On the right hand side, where I have a table with frequency, I multiply minus 40 by 3. So, 3 zeros are 0 and 3 fours are 12. So, the answer is minus 120. Minus 20 into 6 should be minus again 120 and so on. So I would complete the table. Here's the table for your reference. So on the left hand side, I have summation FD, and on the right hand side, I have summation FD. If you notice, the summation F is 7 observations here, and here it is 175. The formula is mentioned for you, which is x bar, which means mean, is equal to a, the assumed mean, plus summation fd upon n. So let's calculate. So I write x bar equal to a plus summation fd upon summation f. What was our assumed mean? If you remember, we considered 140 as our assumed mean, plus summation fd was 140 divided by 7. So if we go ahead and calculate, it would be 140 plus 140 divided by 7 should be, oops, 20, and my x bar is 160. If you notice, this was the actual mean that we calculated using the direct method. Let's come to the right hand side with frequency. So here you have summation x bar is equal to a, again 140, plus summation FD is 9540 divided by, rather than 7 observations, I have 175 observations. So I do the calculation, 140 plus 54.1514. Sorry. So the sum total or the average is 194.514. If you notice, the indirect method and the direct method obtains the same answer. It is your choice when to use. My recommendation to use the indirect method would be when you would have a lot of frequency. Also, if you have bigger numbers rather than 100, 200, if you have 10,000, 1 lakh, the deviation method is much easier rather than the direct method. I hope you've understood the difference between the indirect and direct method. Just to recap, for the indirect method, there are few steps. First, you would calculate D, which is the deviation, which is x minus a. Assume a particular, assume mean. In my case, I took 140, you could take 160, 180, 120. Find the deviations from that assume mean, calculate FD, and then your formula would be x bar is equal to A plus summation FD upon summation F. So I considered 140 as my assumed mean plus summation FD was my deviations multiplied by the frequency divided by the number of frequency, which adds up to the same x bar or average. Hope these calculations were clear to you. If you have liked my explanation and it makes sense, do give a thumbs up to my channel, or please go